Hello guys, let's derive the formula for angle between two lines. Now, you can say this is case 1 and 2, but they'll have the same formula. So, let's just write the formula over here, which we have kind of memorized. So, tangent inverse of absolute value of m1 minus m2 by 1 plus m1 m2. Now, in some cases, instead of modulus, there is plus minus, but that's basically the same thing. It's to make the inside positive. Now, let's see where we actually got this formula from. Now, let's see for the first case. This is what I like to call when the two slopes are, well, both in inclination. When they have both the same rise, the same sign of rise and run. So, as you can see, both m1 and m2, they are both increasing in their rise and also increasing in their run as well. Rise being y-axis, going y-axis, run being going x-axis. And in fact, the case is similar to that of the both being declination, where both have decrease in run as well as rise. So either both are increasing or both are decreasing, they'll be listed as the same because the derivation works the same. But in this case, they are different. Here you can see the rise and run is, well, positive, right? It's increasing. But here you can see the rise is decreasing and the run, well, run itself is increasing. So case 1 is when both rise or run are both increasing or decreasing. And here case 2 is when either the run or rise are either opposite, or either one increases or the other decreases, and vice versa, like that. So let's begin with number 1. So in fact, I'm going to draw like this and like this. Now, in a line, if you take a right angle triangle or just complete the triangle, you get a right angle triangle. And here, let's say you have an angle alpha over here. Well, the tangent of this angle will actually give the slope of this line. It may look like a curve, but it's a straight line. So that's one important fact that we have to use right over here. And another important fact is anywhere in this anywhere in this line making a right angle triangle. So even if you make it right here or right here or right here like this, all of them, the tangent of each of these angles over here will give the slope of the line. So that's another fact that we have to use over here. So first, what I'm going to do, I'm going to make sure that, well, this horizontal line that I create will touch both of these lines below, right? So first, I'm going to complete a triangle for this one, which is M1. And also, I've given an arrow to indicate where the line is going, but here we kind of don't need that. So this, let's call this angle A, and of course we have to find this angle theta. And right over here, I'm going to complete the triangle over here. This both are 90 degrees, and I'm going to call this B. So this is just an angle, not 90 degrees. So this may look a bit crazy, but let's just use what I talked about earlier. So the tangent of this angle, this big triangle over here, this will represent the first slope m1, and this tangent of B represents, well, this m2. Just writing what we know, that is the best way to derive anything. Now we can use a property of a triangle over here. As you can see, we have made a triangle like this. Now we can directly use a property that the exterior angle is equal to the sum of opposite interior angles, namely B equals to A plus theta. Or you can do, this is a straight line, this will be 180 minus B, and sum of them will be 180, but you'll get the same answer. But we just want to account for theta, right? So let's just put theta in one side, and this will be b, in fact this will be b minus a. So now what we can do is, well, we can simply tangent both sides, right? If theta equals to b minus a, then tan theta must be equals to tan b minus a. Now let's solve for tan b minus a. So we know tan a minus b, oh sorry, tan b minus a. So yes, tan a minus b is tan a minus tan b, 1 plus tan a tan b. But instead of a at the front, we have b. So it will be tan b minus tan a, 1 plus tan b tan a. But here we want to make sure that tan b minus tan a is always positive, because here the angle, we really don't want that to be negative because we're solving for this angle over here, the small one. So we're just going to have to put a modulus sign over here. Now this tan b minus a is just tan theta, which is equals to tan b is m2 minus m1 by 1 plus m2 m1. That means theta is equals to tangent inverse, right? But right here you can see we have m1 minus m2, but here we have m2 minus m1. But thanks to this modulus sign, what we can do is, here we can take negative common. This becomes minus m1 minus m2, and due to this modulus sign, it just completely removes that negative sign, because, well, the modulus of minus x is equals to the modulus of x. They are both positive and have the same value. So this in fact just becomes m1 minus m2 by 1 plus, let's just switch this around. It's quite simple. There we go. There is, for the first case over here, and that is a derivation. Now let's account for the second case. So we have our first line going like this, m1, and the second line going like this, m2. This being angle theta. But let's use the fact that I talked about in the beginning, where you can draw the right angle triangle anywhere, which means the slope. So what I'm going to do is, look at this intersection right here. What I'm going to do is, I'm going to draw a right angle triangle for both of the slopes with the same rise, right? So this big angle is obviously theta, and here this angle, let's just say, will be A. This angle right here will be B. Now be very careful over here, because what we are doing here is, we have a line, and then we have taken this angle instead. But as I talked earlier, only this angle, the tangent of this angle, will give the slope. But right here, another fact is, here the cot angle of this, the above one, will give the same slope if this is slope m1, right? And from here we can use the trigonometric identity that cot A is just 1 by tan A is equals to m1. That means tan A is just 1 by m1. So we have to use this fact over here, and it's the same case over here. Tangent A is just 1 by m1, and tangent B, here it's minus 1 by m2. Why minus? Well, this minus sign represents that this slope is in fact decreasing, so we have to put a minus sign. And now we can see that this angle theta is the, well, simply the sum of the two angles A plus B. Put the tangent on both sides, tan A plus B. Now simply just write the formula for tan A plus B. So equals to, tan theta equals to tan A plus tan B, 1 minus tan A tan B, tan, oh this is modulus because here theta must always be positive, as I said earlier, and also because here tangent inverse of anything, let's say x minus x, the negative sign will give minus tan x. So that means our angle will be, well, negative, which doesn't make sense. So tan theta is equals to, let's just put the value over here, 1 by m1 minus 1 by m2 by 1 minus plus 1 by m1 into 1 by m2 over here. So tan theta is equals to, here this will be m2 minus m1 cross multiplying by m1 m2 by 1 plus, here this is simply 1 plus m1 m2. We can take the 1 common, so this is m1 m2 plus 1 by m1 m2. So this and that cancels, giving us tan theta is equals to m2 minus m1 by rearrange that, you get 1 plus m1 m2. And like before, here I'll just put in a little box, theta is equals to tangent inverse of m1 minus m2 by 1 plus m1 m2. Because here taking negative common, modulus sign removes negative sign, like in the previous case. And yep, that is it. That's for the derivation. And we can see how to derive the formula for angle between two lines. And if you learned something new, please like and subscribe. Thank you.